Yesterday we took the quiz and we started compound inequalities. We talked about how compound, it's a compound word, there's two. So we're going to have two inequalities here. So the definition of a compound inequality is when you have two or more simple inequalities combined into one statement by the words and or. So we started out with the first one where it said all real numbers greater than 2 and less than 6. So what numbers are greater than 2 and less than 6? And we came up with a roster of 3, 4, 5. And in algebra, we would write it this way. X is greater than 2 and less than 6. That's actually in words. And down below, algebraically, it's written this way. If you cover up this part right here, and just read that left-hand statement, it says x is greater than 2. And then erase that and just cover up the right-hand part that says x is less than 6. So you can see that you have two inequalities happening here. So over in the graph section, what we did is we drew 3 graphs. So the first graph was just graphing x is greater than 2. Open circle on 2, graph goes to the right. Underneath, x is less than 6, open circle on 6, graph goes to the left. And then we looked at the overlap. We kind of drew a really soft line here and then here. And you can see where the red is, we have an open circle on 2 and an open circle on 6, and every number in between. Now, back over here, these are just whole number examples. The reason we have the heavy bar is because it's all real numbers, which means we could have 3.2, 4.0007. We could put all these little itty-bitty numbers in between. So you can't roster a real number set, but 3, 4, and 5 were just examples of whole numbers that fit. So this would be your final answer. Now, the second example we had, let me go back up here. Sorry. This is called interval notation. So interval notation is something you will see in Algebra 2. And if you remember on the sidewall where you were sitting, you had the signs that say includes and excludes. So it starts at 2 and it ends at 6. And we have parentheses because that means excludes, which means it's greater than or less than. It's not equal. And this looks like what we used to write for coordinates, but for algebra with compound inequalities, this is called interval notation. Now the second one is the same example. It's just a greater than or equal to, less than or equal to. So in the red, we have the same graph. It's just colored in. So it's just going to be colored in right here. And then it's colored in right here. And then the same graph down below looks like this. Same as the one above, it's just colored in because it's showing the inclusion of 2 and 6. In interval notation, we put brackets for the 2 and the 6 because it's showing that it includes. So these are called intersections. So if you go back up here, you'll see this symbol. You might remember that from set theory last year. This is the, looks like the upside down U, and that's the intersection of the two. So in a Venn diagram, like that, it would be that center part that we did with set theory last year. So down below, we have, now you're going to notice that there's ors in here. So you'll see it written this way, and it's going to give you a broader range. So that's the union. So you might remember from set theory, we talked about ors. It was including everything. So it was both. So x is less than 2 or x is greater than 6. Your final answer will be the arrows going in opposite direction. And then when it's greater than or equal to and less than or equal to, same thing, they're just colored in. So what's kind of cool here is we have interval notation for these, and the interval notation is right here. And so we have a union because we need to include both. So it's a little more complicated than just the ones that are ands, the intersection. So here this is negative infinity to 2, union with 6 to positive infinity. And then down below, this is negative infinity to 2, but there's a bracket on this side because it ends at 2, and it includes 2, sorry. And then here with the 6, it is going to include the 6. Why do you think we have parentheses at the ends with the infinities? That's right, it's because they don't end. So you can't include infinity. And then for fun, we did this problem down here. We said, what would this look like in algebraic form? And that's this right here. You're including the 2, which is why you need a bracket, and you're not including the 6, which is why you need the parentheses. And that would be, that's not a roster form, but those are just examples of numbers that would fit in there. We didn't have any homework, and on Monday we're going to start solving for compound inequalities with and.